So this problem is a checkpoint for multiplying polynomials and solving equations with parentheses. It's question 121. This is going to be the last question tonight. I think I've lost question 120. I don't know what happened to it. I do encourage you to do these problems and then go back in the back of the book and check out what's going on there. I'm just going to do problem D because it turns out if you do D, it involves some of the same steps for A, B, and C. So I'll do this one to kind of look at some of the ideas, and then I encourage you to go forward and check your work and practice and ask questions tomorrow too. So if I'm looking at this one, the first thing that I want to do is I want to get rid of these parentheses. Now on the left hand side, it's not too difficult to do that. I can imagine pushing this factor of x into both of these terms, and if I did that, that left hand side would become 2x squared. That's 2 times an x would be 2x squared, and then minus 4 times x. So that's the left hand side. The right hand side, a little bit more complicated, and for a while, certainly, I encourage you to think about generic area models and just to let it organize your work and kind of give it some structure. You'll find shortcuts, you'll recognize shortcuts as you move forward, but for now let's look at a generic area model here. So I'm multiplying two binomials, two terms times two terms, so this is a 4x4 grid. Across the top I'm going to write 2x and then plus 1, and then down the left hand side here I'm going to write an x and a negative 2. So what I'm doing is I'm multiplying the length and the width of each one of these little rectangles and writing down the result. So the first one here is 2x times x, or x times 2x, which would be 2x to the second power. This box next to it right here, the upper right box, is an x times 1, which is just plain old x. The lower left box is negative 2 times 2x, which would be negative 4x. And then finally I've got negative 2 times 1, which is negative 2. Now the sum of those four parts is the product of this binomial times binomial. And if you look at it, what do we have? We've got 2x squared. They're like terms and we can combine them, right? If we combine negative 4x and x, and if I combine those two, I get negative 3x. And then finally there's a negative 2. So this is the right hand side of the equation. So I didn't leave myself enough room here really to do this, but let's write this over here, and let's grab this right hand side of the equation and bring it over as well. So now what I'm doing is I'm just setting this left hand side equal to the right hand side. First thing I want to point out is both sides, left and right hand side, have a 2x squared. So I'm going to subtract that from both sides, and when I do, good things happen. The variable with the squared term disappears. So this becomes 4x equals, or I'm sorry, negative 4x equals negative 3x and minus 2. I can add, I guess I'll add 3x to both sides. That would give me negative x equals negative 2. And then finally I'll multiply both sides by negative 1. And that gives me that x is the number 2. So x is 2 is a solution. I'm pretty confident that, but never so confident that I wouldn't check it. So I'm going to just push in a 2 here, 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 and here, and check my answer. So I've got 2 times, in the parentheses, 2 times 2 minus 4. Let's see, 2 times 2 is, ooh, interesting. 2 times 2 is 4. 4 minus 4 is 0. This is 2 times 0. This is 0. So the left-hand side became the number 0. Over on the right-hand side, we've got 2 times 2 plus 1 in our first set of parentheses, times 2 minus 2 in the second set of parentheses. So this first set of parentheses is 4 plus 1, which is 5, but I end up multiplying that by 0, so it becomes 0 also. So when x is 2, right, that forces the left-hand side and the right-hand side of that equation to become 0. So x is 2 is most definitely the solution.